Hi everybody. Hope you all had a really happy new year. And so I'm in the middle of repairing one of my pieces of test equipment, my ICO 950 capacitor checker, and I'm going to do a video on that as well as a little short tutorial on capacitor checkers, some of the similarities and differences on them and how to use them, and what kind of capacitors work well with what kind of tests. So we'll get into that a little bit later. Right now I wanted to take some time to answer a few questions. I keep getting a lot of different comments and things on the different videos and try to keep up with some of these questions as I can. The first one that I want to cover deals with the audio dummy load that I built and did a video on a while ago. And you can see it up here, all right, in the back of my bench. And you can see it has your inputs for your speakers, your outputs that goes to the voltmeter that I use to measure the watts, and then two scope probes, times 1 times 10 multiplier for the scope, and then just switches to turn on or turn off these outputs. Okay, so let's go back down. And I was asked about a schematic, if I had a schematic, and I was also asked just recently to clarify this whole section for the times 1 times 10. So we'll talk about that in a minute. Basically all we have, right here I have drawn one of the two channels. So there's actually two of these circuits for a stereo dummy load, okay? So you can see right here, first of all, I have two banana jacks. And I do have them polarized, plus and minus, even though sound, out of your amp is AC, not DC. But you want to connect, if you're going to have stereo, you want to make sure that you connect your speakers in phase, especially when you're going out to an oscilloscope. If you're looking at waveforms because you want to look for things like phase inversion or something like that, you want to make sure they're both connected in the same polarity. Okay, so make sure that both the grounds are referenced to the same ground here. Okay, so that being said, the first thing that we have here, if we just take this part, this is sufficient right here to be a dummy load for your stereo. So you can see basically all I have is the two BNC jacks that go to the speaker leads, and then the two output jacks. And basically all I did was the on-off switch just goes right here. Okay, that allows us to turn these jacks on and off to take, if you want to take whatever this is connected to out of the circuit. You may also want to connect another speaker across here or something, which would change this load and everything. We're not going to get into that right now, but for whatever reason, if we want to shut this off, we can shut it off. Okay, so that's pretty simple. And the resistor is dead on 8 ohms. I mean, if you measure those resistors, I was surprised for having purchased them at a reasonable price online. I was really surprised how accurate these resistors are. And they're rated at 300 watts, and I have them on a big aluminum channel heatsink, so they can really handle a lot of power. Now, the big question comes into play is with this voltage divider. All right. I think I had originally stated, and I may have corrected myself, I'm not sure, on the video. I'd have to go back and watch it. And I confess I did not go back and watch it. So there may be a little error, and hopefully this video will clear it up. But basically, this is a voltage divider. Now, why do we have a voltage divider? Well, I may not necessarily want the full voltage. If you get into a 100 watt or 200 watt amplifier, you start getting quite a bit of power coming into this. And if you go into your oscilloscope, you may overload your oscilloscope if you just directly connect that power right into the input of your scope. So it's nice to be able to cut that down to a manageable level. So basically this is set up to give us roughly a 10-to-1 ratio. Okay, now where I may have made a mistake is I think I had this originally spec'd out as like a 100K and a 10K resistor. And when you do that, it comes out to actually around 9 to 1 roughly. Okay, so it's not exactly 10 to 1. Now, for my use, that would have been just fine. I wouldn't have cared, but it kind of bothered me. I went in and fixed it, later on. But bottom line is, in order to figure this out, first of all, you're going to find out trying to find odd value resistors is not always the easiest thing. And you also have to look at what purpose this is for. To measure actual output power, I use a true RMS meter, and I measure directly across the speaker leads like this, across this load, without any influence of this, okay? This here is just giving me a visual representation of the waveform. So even though it may not be 100% accurately exactly 1/10, okay, it's still giving me a close representation of the waveform. If I use this to, if you notice, whenever I do my videos, I always measure the power off of my meter, and I look at the actual distortion and waveform and all that on my oscilloscope, but I don't use the scope to measure the power, okay? Now, even this right here, if you look at it, 100K and an 11K. So basically I have 100K here and 11K here, okay? The math formula for a voltage divider for resistors equals your V out in your divider, so V out divider, V out div divider, equals your input voltage, which is right up here, okay, times the quantity of this resistor, okay, divided by all of the resistors added up. So in this instance, okay, it would be 11,000 ohms, because you have a 10K and a 1K. And why did I do that? 10K and 1K are readily available. You can buy them in 1% precision resistors, and they're inexpensive. And even if you, half the time you don't even have to buy them, you can get these at Radio Shack, or usually you have them, multiples of 10 resistors, 100K, 10K, 1K, so forth. Those are the most common values, so you have them on hand. If we use that formula, we're going to take 11,000, which is these resistors here, which is R2, which is this total here. So I got a 1K and a 10K in series inside that box up there. And then I'm going to divide that by all of these added up, which would be 111K. Okay? So if you take 11,000 divided by 111,000, you're going to find out it roughly comes out to about 0.991, and I'm rounding it off there, okay? So for all intents and purposes, that is approximately a tenth, or a 10 to 1 ratio, okay? If you want to be a hair splitter, okay? All you mathematicians that are cringing right now because I'm saying that, yes, you are 100% correct. It is not exactly 10 to 1. It is 0.09909 and a big long thing to 1. But that, millivolt or so isn't going to make that big of a difference in your measurements, okay? If you're trying to get really hyper accurate for, you're using you have like a comparator circuit you're building or something, then I would suggest putting in, on this 1K, put in like a 2.2K potentiometer or something like that, and be able to fine adjust this to adjust out every little anomaly in here. And you can get a perfect 10 to 1 ratio. You'd put a really accurate 1 volt power source across here, like from your bench power supply, get exactly 1 volt, measure exactly 100 millivolts here, adjust this pot. I didn't need all that. Really, all I needed was roughly a 10 to 1 representation so I can see on my scope. And for all of you, for most of what you guys are going to do, you're going to find out that that's the same. Now, there's another option. The next normal value up of resistor on this would be like a 1.2K. And if we use a 1.2K resistor, you go down here, I figured it out to be about 0.1007 to 1. So it's going to be a little more than 10 to 1. Okay, 10.07 to 1 ratio. Okay, again, either way, it's going to be off by a little hair, by a few millivolts. But again, you're dealing with volts when you're looking at the output of an amplifier. So a couple of millivolts really aren't going to make a difference on here. Now, in the event that you wanted to use your scope to measure DC offset on the amplifier, so you've seen me on some of the bigger amps, like on the SX1050, where we adjust DC balance so that there's 0 millivolts across the output terminals. Technically, you could do that. You would want that to be more accurate, but in that instance, you don't want any load. If you look at most of the instructions out there, they tell you to disconnect any load from the speaker terminals and just plug your voltmeter directly into the speaker terminals and read it that way. So once again, I don't see a scenario where we're going to need this to be super accurate. Again, I could have put a pot in here and fine-tuned this perfectly, but then you're just putting another component in there that can get corroded or get problems down the road and fail. And I don't like things to fail. I like them to work and work for a really long time so I don't have to keep fixing them. So for me, this is good. So I basically have 0.0991 to 1, or in my mind, 10 to 1. Okay? Horseshoes and hand grenades, close enough. Anyways, so that's how this works. Okay? Then I put a switch on my BNC connector, and when it toggles up this direction, I'm just looking directly at the output. So if I'm looking at a little amp that only puts out 1 or 2 watts, I may want to have 1 to 1. Okay? If I'm looking at a big monster amp that can maybe put out, 60, 70 volts on this terminal, on these terminals here, I'm going to go down to 10 to 1 because, again, I'm connecting directly a BNC wire from here to the input of the scope. In other words, I'm not putting a times 10 oscilloscope probe in there. So this has to take the place of my times 10 probe. Okay. Now, could I have just put a little hook here and use just a times 10 probe for my scope and get super accurate? Yeah, I could have. I could have done that. I just think it's messy to hang your scope probe on stuff like that, and this way, I just have my 2 little BNC wires permanently installed up there. They just go straight over to my scope up here that you can see. And I can connect or disconnect them as I need, and it's a direct reading. And then if I want to toggle between times 1 and times 10, it's just as simple as that. Okay? So that's why I did it that way. I hope that clears up a little bit of the confusion. And again, I apologize for misrepresenting a little bit of this whole voltage divider thing. Again, there's the math for it if you want to figure it out for yourself. And you can find out that you can fine-tune this as you go along, okay, and get it more accurate. But really, if it's that important to get accuracy, use a pot. Use a potentiometer here, just a fine trimmer pot, like, add another, add a 2K pot right here or something, and then like a 10 turn 2K pot, and you can fine tweak this until you get exactly 10 to 1, okay, if you need that much accuracy. All right, so that's the answer to the first question. All right. Okay. My next question that I received, and I've had 2 or 3 or 4 times I've heard this from different viewers, is why don't I take, the finished product when I finish up one of these amps, instead of just showing you a sine wave on the scope or playing on my little Radio Shack Minimus 7 speakers, why don't I hook it up to a big set of speakers and try to get a good recording of it and so forth? Well, there's a couple reasons for that. Number one, I think that would be really cool if I could do that. That would be really neat. But there's a couple good reasons. Number one, The editing, the extra editing, extra time. I do have a really good digital USB microphone that I could use to record sound. But again, it will never faithfully reproduce what that amplifier is really doing in real life. Second of all, the editing itself is going to take a lot of extra time, because if I have to overlay another audio track on top of the video, the audio that's in the video itself, that's going to take extra time and extra editing. Third of all, I would have to take it over to my basement system and connect it to the big speakers. I have a good set of Klipsch reference series, and again, they sound wonderful, but there I would have to connect them, connect the amplifier, put a source on there, and then place the microphone, and it's still not going to sound on your little YouTube video compressed audio, whatever they do on YouTube, never ever going to sound like it does in real life. So it's kind of a fruitless endeavor, from my opinion, to do that. Again, I really wish you could hear some of these things, how they sound when they're completed, especially if you listen to a stereo before it gets redone, before everything is adjusted, before all the noisy transistors have been replaced, and before all the imbalances have been adjusted out, and before all of the capacitors that were leaky were replaced, and then after all that work had been done, the difference in the sound is really, it's phenomenal. But a microphone won't pick most of that up. And even me at my age, my ears don't even hear like they used to. I mean, as we age, it's just a fact of life. Most people, your high frequency response of your ears goes down. The older you get, the less range of audible frequency your ears can pick up. And that's just a fact of life. Some people are blessed with the ability to have really good hearing at older ages, but I'm not one of them. So I still really enjoy good audio and good sound, and I can hear the difference, but I have to confess I can't hear the highs like I used to be able to hear, all the little nuances of of when you're listening to a really good turntable on a really good set of speakers with a really good amplifier. I can't pick that up anymore like I used to. So anyways, that's the reason that I don't do that. And again, from time to time, if I have the extra time, I'll try to do a little better job of demoing some of this stuff. The other thing is I'm not the biggest YouTuber on earth. I'm still new to this, and I don't want to get in trouble with copywriting and stuff like that. So, how much can you get away with and not get away with? That's a varying opinion when I talk to people. And then you try to play the public domain stuff, and it's not the same as songs that we're all used to listening to. So once again, that's the reason that I don't do all that. All right, the next question deals with receivers, or actually like shortwave radio receivers, AM radios, things like that. And somebody asked me about how to align the dial for accuracy so that all the way from the bottom of your dial to the top of your dial, the frequency is accurate to the pointer. So if your pointer's pointing at 1.6 megahertz, or 1600 kilohertz, you're actually on 1600 kilohertz station. Okay, and when you're all the way down on 570 kilohertz, your pointer is really pointing at 570 on the dial. So it's a lot more of a question a lot more of an answer than just simply do this. So let me go through a simple alignment, okay? So if you look at how we do this, okay, like an alignment, the first thing you're going to do is you have your physical dial here, okay? So this is the back of the radio from the inside, and you're looking here as you have your frequency dial. and it's connected to the tuning capacitor right here, your capacitor gang, and it's connected with a little set screw on a little shaft. And the first thing you want to do is you want to completely move that tuning gang to one end or the other, usually all the way closed, for instance. And then you're going to move the dial all the way to that end, and you're going to line the pointer up to the far end alignment line on the dial, okay, mechanically, and tighten it down. Okay, that's your first thing you're going to do. So you do your mechanical alignment first. Usually that's what the directions tell you to do. Okay, now the next thing you're going to do to get it to be accurate, okay, if the circuit is good, if all your components are correct, and that's the really important caveat here, the components in the receiver have to be correct values. If they've drifted, if they're not right, I'll get into that in a minute, it's not going to work. So if those are all correct, you're basically going to do two different adjustments. And usually what you're going to find out is at one end of the dial, you're going to adjust your capacitors, your tunable capacitors, like the little caps on here and so forth. And at the other end of the dial, you're going to adjust your slugs on your coils. Okay. And basically what they have you do is they start you out. So right here, this is the AM section of this radio. This is a multi-band shortwave receiver. So it's got, 4 bands on it. But let's just talk about the AM, because all the other ones are the same. They work the same. So if you notice, you start at the top of the dial, 1500 kilocycles, okay? And typically the AM band maxes out around 1600, okay? So they're going near the end, the high end of the band, okay? And you're adjusting right here, okay? J, K, and L, whatever those are, okay? So we're just adjusting those cans or those slugs or those capacitors, whatever it tells you. Then you're going to go to the other end of the dial, 600 kilocycles. You see that? Now you're going down, and you adjust this other one, okay? And then you're going to go back and forth, repeating that until one no longer affects the other. In other words, you're accurate on both ends. That's really all there is to getting the dial to be accurate. Now, let's talk about that caveat that I was mentioning, okay? Let me get a schematic out. So here's a schematic for that same receiver. And if you look down here and here, okay, you have your tuning gangs, and these are for your 4 bands, 1, 2, 3, 4, 1, 2, 3, 4. This is your RF, so this is your antenna tuning. This is actually tuning the circuit to be resonant to whatever station you want to pick up on the antenna, okay? So this is your tuning section. This is called your local oscillator section, and I talked about this a little bit on my last video on the SX750. Your local oscillator is basically set to a frequency that is a certain distance away from this one. In this instance, it's 455 kilohertz difference. So you got 2 different bands that are 455 kilohertz apart, okay? And then you're subtracting the 2 and coming up with an intermediate or IF frequency. But we'll get in, we talked about that. We're not worried about that right now. What my point is, if you look at these tuning gangs, there's little capacitors in here, okay? You see all these little capacitors here? And some of these, the ones that are not used for coupling, like this is a coupling capacitor. If it's off a little bit, it's not the end of the world. It's just trying to block DC and pass the RF through it. However, some of these caps, you'll see some like this down here. You see some of these, okay? You see this one's adjustable. You see these? Some of those are very specially hand-picked at the factory when they build each individual radio. They're hand-picked to work accurately with the circuit, because there may be tiny little differences in every radio. So they may have made 50,000 of these S40B Hallicrafters, but they may all be slightly tiny bit different. So what they'll do is they'll pick capacitors in here that will work the best and give them the best dial accuracy. Now, a lot of people, it's a rookie error. They come in and they want to quote unquote recap the whole radio. You know, you hear replace the capacitors, replace all the capacitors, they're all bad. Well, to a degree that's true. There are certain ones, like all the coupling capacitors, all the filter capacitors, all these things, you do want to replace those. Anything that involves frequency adjustment, like these little silver mica capacitors, you know, they're mica, they're very high accuracy capacitors. Unless they are physically bad, never ever touch them, never replace them. Those are the ones that control the oscillators and control the accuracy of the radio. If you innocently pull one of these caps out and you replace it with a brand new one that might be dead on exactly the right, this is 3,000 picofarads, and you take this one out and you put in a perfect 3,000.0 picofarad capacitor, thinking you're making your radio more accurate, all of a sudden on this band the dial won't be accurate all the way. It'll start drifting off of accuracy as you go up and down the band. Okay, it's because they may have chosen one that's 3,050 picofarads simply because that's what it needed to match up properly with this coil and make it accurate. This happens in these old radios. Newer ones you don't have that much so much, but when you're dealing with these old tube sets and stuff, these capacitors get very, very critical. So anything in the oscillator in the front end section, you really, if the oscillator is working and you can tune it, don't mess with it unless it's way out. Now, in the event that you go through the entire directions and you follow this to the letter and you're sure you're doing everything correctly, okay, and it's not accurate across the dial, then what in fact may have happened is one of these capacitors may have started to go bad. Okay, not very often, because these mica capacitors are a lot more durable than the wax paper caps. But again, if that is out from where it was when they first built the radio, that could throw your dial accuracy off to the point where no matter how you adjust these three adjustments here, it'll never be accurate all the way. It'll always have a little bit of drift, and that's because one of these is bad. But that's a absolutely last resort, last ditch effort when you replace those. And when you do, you may have to go through 2 or 3 different values that aren't necessarily dead on to get it right. Okay? Hope that answers your question on that. So, I don't want this video to get too long. I just wanted to cover a couple of the bigger questions. Again, look for the capacitor tester video coming out. And hope you all have a great day, and more to come later. One last quick thing. I just wanted to let you all know that I apologize in advance. From time to time, you get working on these things, and you're trying to think about what you're doing, and you're trying to explain it to the camera at the same time, and you're talking to yourself because there's nobody really here. And from time to time, we make mistakes and we misspeak about things. I really don't mind when you guys call me out on that, because that gives me a chance to fix it. And I see other people on other videos, other channels do the same. But, we put a lot of spare time in to help you guys learn some things and to share our knowledge, what we do know. So just understand that we're not perfect, and we're not always going to get things perfect the first time. But if you're patient, I'll be happy to help you with whatever I know, and when I'm wrong, I'll admit it, and I'll try to make it right. And if you do see that, hey, we correct each other, and it just makes us all that much better. So, again, thank you guys. Thanks for watching. Thanks for coming along on these videos, and thumbs up if you think we're doing okay here. Thanks, guys.